Dear students, numbers do not feel, do not bleed, or weep, or hope. They do not know bravery or sacrifice. Love and allegiance, at the very apex of clousiness, you will find only ones and zeros. Yes, today in this video we are going to learn about number system. We are going to explore more about number system. So now we use numbers to represent values. When we count any object, we represent the counted value by the numbers like 0, 1, 2, 3, 4, 5 and so on, etc. There are different types of number system that we can use to represent a value. The different number systems use different digits or symbols to represent numbers. When we type some letters or words, the computer translates them in numbers, as computers can only understand numbers, that also too in binary form. A computer can understand positional number system, where there are only a few symbols called digits, and these symbols represent different values depending on the position they occupy in the number. The value of each digit in a number can be determined by using the digit. The position of the digit in the number, for example, whether it is the position is in the ones place or tens place or hundreds place. So the base of the number system, where base is defined as the total number of digits available in the number system. Now the different number systems have different base number. Different number systems they are. First one is decimal number system. You can see over here this decimal number system, base 10, and digit used is they are 0 to 9, that is 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. And the second one is what? Octal number system. Base is 8 and the digits used in this number system they are 0 to 7, 0, 1, 2, 3, 4, 5, 6 and 7. And the next is hexadecimal number system, that is base 16 and digits used over here in is 0 to 9 and the letters used are A to F. So what are the total number of digits over here? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and then A, B, C, D, E, F. A over here is 10 and B over here is after 9 it is 10, no? So and B over here is how much now? 11 and C is 12 and D is 13 and E is 14, F is 15. But total number of digits over here is 16 only, including 0. And then next is binary number system. Base is 2, then digits used are 0 and 1. So now first we will learn about decimal number system. A number system that uses 10 different digits to represent a value is known as decimal number system. It is also called denary number system. The base of decimal number system is 10. So the number system that we use in our day-to-day life is the decimal number system. The decimal number system has base 10 and it uses 10 digits from 0 to 9, that is 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So how many total? Total 10. So in decimal number system, the successive positions to the left of the decimal point represent units, tens, hundreds and so on. So each represents a specific power of the base. For example, the decimal number system 1, 2, 3, 4 consists of how many digits? 4 digits. And then in the digit 4 is in which position? Units position. And whereas 3 is in which position? Tens position. You have learned all this in your maths also. So 3 is in which position? Tens position. And then 2 is in hundreds position. And then 1 is in which position over here? 1 is in thousands position. So its value can be written as, we can write the value in expanded form as, since 1 is in 1000 positions, we multiply 1 by 1000. And then since 2 is in hundreds position, plus 2 into 100. And then again plus 3 is in tens position, 3 into 10. And then 4 is in ones position, that's why we write 4 into 1. So now this 1000 we can write it as, since there are 3 zeros, so 10 to the power of 3, and then 1 into 10 to the power of 3 plus 2 into, similarly 100 we can write it as 10 to the power of 2, because 10 times 10 is how much? 100. So and plus 3 into, this is only 10, so we are writing just 10 to the power of 1. And then dear students, do you remember anything to the power of 0 is 1? So instead of writing 1 over here, can I write 10 to the power of 0? So I have written the same thing. And now when we calculate this, this 1 into 10 to the power of 3 is how much? 1000. And plus 2 into 10 to the power of 2 is how much? 200. Plus 3 into 10 to the power of 1 is how much? 30. And then 4 into 10 to the power of 0 is how much? 4. So there it gives us this number 1, 2, 3, 4. I've just given you this example. We can take assume any other number also. And now next, binary number system. So in binary number system, it uses two different digits known as binary digits. So it has just two digits, 0 and 1 is non-zero number. So also called, it is also called base 2 number system. Each position in a binary number represents 0 power of the base 2. So example, 2 to the power of 0. 2 is the base over here, and then 0 is the power. So and then last position in a binary number represents x power of the base 2. So example, 2 to the power of x, where x represents the last position, 1. So example, while converting from binary to decimal, what we need to do now? Binary number, for example, it is made up of only 0 and 1. So this is, I have given you one simple example, 1 0 1 0 1, and the base is 2. Of course, binary number, they are having the base 2. Now how will you convert that in decimal? So I have given you this stepwise process. We need to follow these steps for the conversion of binary to decimal. So first what we need to do, we will multiply all the numbers, all the digits in this number with 2, and then starting from the right side, we will start giving the powers of 2. So 2 to the power of, we will start from 0. So 0, and then 1, and then 2, and then 3, and then 4, and then in between we will add them up, and then after adding them up, now this 2 to the power of 4 is how much? 2 2s are 4, and 4 2s is 8, and 8 2s is 16. So we are multiplying 2 4 times, and plus 0 into anything is 0 only, so we don't have to multiply this also. And then plus 1 into 2 to the power of 2 is how much? 2 times 2 is 4, and so 4 into 1 is 4. and then 0 times anything is 0 only, so I have not even multiplied. So plus 1 to anything to the power of 0 is how much now? 1, and 1 into 1 is 1. And then now since it is getting converted into decimal, I have kept over here this 10 as base. Since decimal number, it is having the base 10. And now after that we need to just add them up. 16 plus 4 is 20, and 20 plus 1 is 21. So now this binary number 10101 to the base 2 is equal to how much now? 21 to the base 10. So this 101012 is normally written as 10101. Next is octal number system. So now what are the characteristics of this octal number system? Octal number system is the number system that uses 8 different digits. The base of octal number system is how much? 8. And which are the digits used in this? 0, 1, 2, 3, 4, 5, 6 and 7. And the number system, the other numbers in the octal number system are formed by combining its 2 or more digits, like 1, 5. Combination of what? 1 and 5. For example, 107. It is the combination of these digits only, 1, 0 and 7. And then each position in octal number system represents 0 power of the base 8. Example over here, 8 to the power of 0. So last position in an octal number represents x power of the base 8. Example, 8 to the power of x. 8 is base over here and x is power, where x represents the last position. Now, example how to convert octal to decimal. So now, for example, you are given with an octal number this 12570. It includes only digits from 0 to 7. So that's why it is a octal number, and the base is what? 8. So now how to convert? I have given you these 3 steps over here. If you follow this very nicely, then you can easily convert from octal to decimal. Now 12570, we need to multiply each and every digit by 8. And first we multiply each and every digit by 8, and then we will, in between we will put a plus sign. For example, this 1 we need to multiply that by 8, and 2 also by 8, and in between we will keep plus, and then plus, and 5 by multiplied by 8, and then 7 also multiplied by 8, and then last one is this 0 also multiplied by 8. And now start keeping the power. You will start from this right side, start from 0, 0, 1, 2, 3, 4. And now if there are more digits, it can go up to 5 and 6 also. So like this. And now in which this number system it is getting converted to? It is converted into decimal number system. So I have kept over here 10. Okay, base 10. So now solve this. 8 to the power of 4 is how much? 8 into 8 into 8 into 8. 8 multiplied 4 times. So that is 4096. Into 1 is how much? 4096. And then plus 8 to the power of 3 is how much? 8 into 8 into 8. 3 multiplied 3 times, and then again times 2 is how much? 1024. And then plus 8 to the power of 2 is how much? 8 into 8. And then multiplied by 5, it comes to 320. And then similarly 7 into 8 to the power of 1 is how much? 8 to the power 1 is 8 multiplied 1 time, and then into 7. 8 into 7 is 56. So I have kept over here 56. And then 0 multiplied by anything, it is 0 only. So now we will add this all up and then write it finally over here. Okay, the answer will be 15496 to the base 10. So now this is how we can convert octal number system into decimal number. So now next is hexadecimal number system. Now what are the characteristics of hexadecimal number system? So hexadecimal number system, it uses 16 different digits known as that's why it is known as hexadecimal. So the digits of hexadecimal number system, they are 10 digits and 6 letters. That is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then A, B, C, D, E, and F. So letters represent numbers starting from 10. Why 10? Up to 9 it has already it is already over here. And A is what? The value of A is how much? 10. And B is 11. And C is how much? 12. D is 13. E is 14, and the last F is 15. So also it is also called base 16 number system. Now each position over here also position in hexadecimal numbers represents a 0 power of the base 16. For example, 16 to the power of 0, where 16 is the base and 0 is the power. Last position in hexadecimal number system represents x power of the base 16. Example, 16 to the power of x, or 16 is the base over here and x is the power, where x is the last position. Now next, how do we convert hexadecimal number into binary number system? So now the steps for converting. So hexadecimal, I have given you a simple example, 19FDE to the base 16. So this is now in hexadecimal form. So how do we convert? What is the first step you need to do? Since the base is 16, we will multiply all the digits by 16. So 1 into 16 and then 9 plus 9 into 16 and then F into 16 plus D into 16 plus E into 16, and then start keeping the power from the right side, 0, 1, 2, 3, 4. And then now next what we need to do, 1 into 16 to the power of 4 as it is. And now instead of this over here F, we will keep what? We will keep, because I've told you in my previous slide also, the A means how much? A means 10, and then B means 11, C means 12, and then D means 13, and E means 14, and the last F means how much? 15. So that's why the value of F over here I have kept 15. And then into 16 to the power of 2 plus D, similarly I have kept over here 13, and into 16 to the power of 1 plus E I have kept over here 14, and into 16 to the power of 0, and then it is converted, since it is getting converted into decimal number system, I have written over here 10. So now you will similarly calculate this all. 16 to the power of 4 is how much? 16 you need to multiply 4 times, right? 16 into 16 into 16 into 16, and then plus 9 into 16 multiplied 3 times. So 16 into 16 into 16 into 9. So then you will get this much. And then 15 into 16 into 16. So you will get 3840. And then 3 into 16 to the power of 1 is 16. So that's why you get how much? 208. And then last one, 16 to the power of 0, anything to the power of 0, 1. So I have written over here 14. And now when we add up, finally we will get how much? 106462 to the base 10. So now this is converted into how which number system? decimal number system. So this is the process how we convert hexadecimal number into decimal number system. Next, number conversion. So there are many methods or techniques which we can be used to convert numbers from one base to another. We will demonstrate here the following: decimal to other base system, other base system to decimal, other base system to non-decimal, and then shortcut method also we will learn. Binary to octal, octal to binary, and then binary to hexadecimal, then hexadecimal to binary. Now first, decimal to other base system. When you will follow all these steps stepwise, you will be able to convert the any decimal number to the other base system. So first step, what will be the first step? Divide the decimal number system to be converted by the value of the new base. That means, what do you mean by this? We'll take an example in the next slide. So get the remainder from step 1 as the rightmost digit, least significant digit of the new base number, and then divide the quotient of the previous divide by the new base, and then record the remainder from step 3 as the next digit to the left of the new base. Repeat these steps 3 and 4, getting the remainders from right to left until the quotient becomes 0 in the last step. The last remainder thus obtained will be the most significant digit, MSD, of the new base number. Now for over here, decimal number system, I have taken one example, 29, and then the base is since the decimal number system the base is 10. So how we can calculate, how we can convert into a binary number system? So first you need to divide this by 2. So after dividing this by 2, how much you got? 14. 2 14 is 28, but remainder is how much? 1. So we write remainder over here in this another side. And now 14 divided by 2, again here you got 14, the result, you again divide that 14 by 2. So 2 7 is 14, you got 7, and now here remainder was 0, isn't it? So I wrote over here 0 remainder. And then again take this 7 result, and then 7 divided by 2 is again how much? 2 3 is 6, but here it is 7. So remainder is how much? 1. So remainder over here 1. And now again 3 divided, the result is 3 over here, the last result. So 3 divided by 2 is how much again? 1. So remainder is again 2 1s is 2, but here is 3, so remainder is 1. So now at last 1 divided by 2 is how much? We cannot divide, so we will write 0, and the remainder is how much? 1. So now if you follow this stepwise step process, the remainder at last you are getting at last you will get, in the result you will get 0, and the remainders have to be arranged in what order? Reverse order, from the this bottom to the top. So you have to arrange the first remainder becomes the least significant digit, that is this first one becomes the least significant digit, and this last remainder becomes the most significant digit, that is to be written initially over here. So like this you will write 1 1 1 0 1 to the base 2. Yes, I hope you have understood. If still you haven't understood, you can connect me. 101 is equal to how much now? This is equal to 5 to the base is 8. And now 010 in octal number we can write it as 2 to the base 8. So now here you have got here octal number 25 to the base 8. Now binary number, this 10101 to the base 2 can be written as 25 to the base 8 in octal number system. So these are the steps to convert binary number system to the octal number system. So now shortcut method to convert octal to binary. So convert each octal digit to 3-digit binary. That is, the octal digits may be treated as 2 decimal for this conversion. Combine all the resulting binary groups of 3 digits each into a single binary number. Example, over here I have given you a short example, 5 to the base 10, 25 to the base 10. So how do you calculate now? 25 over here to the base 10. While converting into this octal into binary, you will write 2 to the base 10 and then 5 also to the base 10. So here what is this 2 to the base 10 means 0 1 0, and then 5 to the base 10 means what? 1 0 1 to the base 2 in binary number system. So now 0 1 0 and then 1, your answer is 1 0 1 0 1 to the base 2. Next, shortcut method now to convert binary to hexadecimal. So divide the binary digits into groups of now over here 4, starting from the right side. So convert each group of 4 digits to one hexadecimal symbol. Example, now here I have given you a simple example, 1 0 1 0 2 1 0 1 0 1, and the base is 2 because it is a binary number system. Now we are dividing this into a group of 4, but here are only 5 digits, isn't it? So first we will start dividing from which side? From the starting from the right side. So in the right side it is 1 0 1 0, no, and then last one is left. To complete this also, in a group of 4 we need to keep 3 zeros over here, so that it will become 4. So now what is this 0 0 0 1? Now we can keep this one as 1 to the base 10, and this 0 1 0 1 means how much? 5 to the base 10, and now this is total how much now? 15 to the base 16. So this is how you can convert binary number system to hexadecimal number system. Now what is the shortcut method to convert hexadecimal to binary? Now first, convert each decimal digit to a 4-digit binary. The hexadecimal digits may be treated as decimal for this conversion. Combine all the resulting binary groups of 4 digits each into a single binary number. Then you will get, so for example, hexadecimal number, I have taken this over here, 1 5 to the base 16. Now how will you calculate? Calculating binary equivalent, 1 5, your base is 16, so it is a hexadecimal number system. And then now binary, 1 to the base 10, 5 to the base 10. Okay, so now 1 is how much now in binary system? 0 0 1 to the base 2, and 5 is how much in binary number system? 0 1 0 1 to the base 2, and then this 15 to the base 16 can be written in binary number system as how much? 0 0 0 1 0 1 0 1 2. Now these 3 zeros you don't need to write, just 1 0 1 0 1 to the base 2. So this is how you can convert hexadecimal number system into a binary number system. Thank you. Stay safe and healthy during this lockdown and get yourself engaged in creative activities. Thank you.